So in the last video, we were going over in section 9.1 about right triangles and using the Pythagorean theorem. Now, for the Pythagorean theorem, you had to be given two of the three sides, the lengths of two of the three sides of the right triangle to be able to figure out what was the third side. Well, sometimes you're not given all three sides. Sometimes you're only given one side, and we ask you to determine what are the other side lengths. Well, one way to do that is if you are given, for example, a special right triangle, and a special right triangle in this case is one that has three angles, two of which are 45, 45, and the third one is 90. One of them is always going to be 90 because these only work for right triangles. So if you happen to have three angles, 45, 45, 90, we have a ratio. There's a very specific ratio of those side lengths to each other. Whatever the length of one, the side opposite the 45 is going to be A. The side opposite the other 45 is also going to have a length of A. And the side opposite the 90, the hypotenuse, is going to have a side length of A times the square root of 2. So what does that mean? Well, if, let's say, we tell you A is 5, so you know that one side of this triangle is 5, then you know that the other side is also 5, and you know that the hypotenuse is 5 times the square root of 2. And so we can utilize this fact to solve missing sides. All we have to be given is one of the three sides in a 45, 45, 90 triangle. So for example here, how do I know this is a 45, 45, 90? How do I know this is even a special right triangle? Well, notice it's definitely a right triangle, and notice that this side and this side are equal. This is an isosceles right triangle, which means that this angle has to equal this angle. If these two angles are the same, then they're each 45 and 45. So once I know this is a 45, 45, 90 triangle, I'm able to use the rules which I learned, A, and A square root of 2. Now here, they didn't give me one of the legs, right? I know X and X, those are the two legs. They gave me the length of the hypotenuse. So I know that A times the square root of 2 equals 6. Well, this is the most difficult problem they could give you here. But again, if I know that A times the square root of 2 equals 6, then I know if I divide both sides by the square root of 2, I'm going to be able to determine what A is. So A is 6 over the square root of 2. So I know that whatever 6 over square root of 2 is, I know that that's the length of those two sides. Now, in math, we have to put things in simplified form, and having a radical in the denominator is not simplified. So we learned that if we multiply the top and bottom by that radical 2, we're going to get a more simplified answer. So far, I'm at 6 times the square root of 2 over 2, and I know that I can simplify numbers that are outside the radical. So this is 3 radical 2. So 3 radical 2 is really the length of A, and it's the simplified length of A. So if you give me this, I know it's correct. However, this one is fully simplified, and it's the preferred version, and it's the one that's going to get you full credit. Now, not all triangles are 45, 45, 90, right? The second and the only other special right triangle is one where the angles are 30 degrees, 60 degrees, and 90 degrees. And these sides also have a special relationship. I know that whatever is opposite the 30 degrees, that side length is going to be A, okay? Based on that, I know the side opposite the 60 is going to be A times the square root of 3, and the opposite the 90 is 2 times the A value, whatever that A value is. So of course, the easiest problem is an example where A is, for example, 5. Well, if A is 5, Then I know the side opposite the 60 is 5 times the square root of 3. And I know the side opposite the hypotenuse is going to be 2 times 5, or 10 units long. So obviously this is the easiest side to be given. But again, we could give you any one of the three, and you can use algebra to find A. And once you know A, you can find all the sides. So let's do that here. So I look at this triangle and I'm like, okay, I have here, they want me to find the value of x. Now I have 30, 60, and they're wanting to know, there we go, that makes it a little bit easier, right? So I've got 30, 60, and 90 degrees. I know the ratio is going to be a square root of 3, and 2 times a. So in this one, I noticed that I was given, that's the example I used in the last slide. Sorry, I know that a is 5. And so again, this is 5 square root of 3, and this is 2 times 5, or 10. Now, let me try to give you some different numbers since I used that same example in the last one. So let's pretend here that this is 10, right? Well, then I know the side opposite the 30 is 10, so this is 10 radical 3. So that would be this side is 10 radical 3, and the hypotenuse would be 2 times 10, or 20. So y would be 20. And so I can do it that way. Now, you might say, well, what if you're not given the side opposite the 30? That's a great question, right? Let's say that I was given the hypotenuse, and I told you that y was 20. Okay, well, if, again, it's a radical 3, and 2a, and if the side opposite the 90 is 20, if 2a equals 20, then I know that a must equal 10. And again, once I know that, I know the side opposite a is 10, opposite the 30, and the 60 degree, the side opposite the 60 is 10 radical 3. And so again, it doesn't really matter which one you're given as long as you apply it correctly. You plug it into these ratios and you find the a value. So again, now we're just going to work out a problem using this. So we've got a square. So first of all, on a square, you know that all 4 sides are equal, right? So let me do a. So I know a, and a. And you know that the diagonal has a length of 6. So this is 6 units long. So again, think about this. I'm dealing with a right triangle. The diagonal in a square bisects the angle. So I know this is a 45, 45 triangle. So 45, 45, 90. And I know the side opposite the 90 is 6. So I know this is a, and a square root of 2. And I know that that side is 6. So if a square root of 2 equals 6, sad part is I think these are the numbers we already used as well. A equals 6 over radical 2. And again, we rationalize the denominator. So this is the same values we've used before. And it's going to be 6 radical 2 over 2, or 3 radical 2. So that means each side is 3 radical 2. So if I'm looking for the perimeter of the square, I know it's 4 times whatever the length is, and the length is 3 radical 2, which means 4 times 3 is 12 radical 2. So my perimeter is 12 radical 2 units. So lastly, we get to this question here, and it tells us that we have an equilateral triangle. So an equilateral triangle, I know it's a terrible drawing, but it basically has all the angles are equal. They're all 60 degrees, and all the sides are the same length, right? So let me just name them x. Let me just name it x. So the perimeter is going to be, obviously, 3 times x. Whatever x is, right? X plus x plus x. Now it does tell us, the only piece of information that they give us, but it's critical, is that the altitude has a length of 5. Now an altitude in this kind of triangle goes down to the center, has a length of 5, and what it ends up doing is it splits the pieces in half. So I know that x is going to be the length of those, you know, together, this whole side is x, right? So if you think about it, this altitude, not only does it split the side into 2 equal parts, it splits this into 2 equal parts. So it's 30 and 30. And notice now that what you end up with is, I'm just going to do the left side here. I'm going to do kind of like this triangle. I've got an altitude of 5, right? And I've got this piece here. Let's call that A. And then I have this hypotenuse there that I don't know. So I'll call that A, right? So I know that this is 60, and I know that this is 30. So remember that in a 30, 60, 90 triangle, it's going to be A radical 3, and it's going to be 2A, right? So the side opposite the 30 is my A. The side opposite my 60 is 5. So I'm able to use algebra to figure out what A is, right? If I know that A square root of 3 equals 5, then I know that A is 5 over the square root of 3. If I want to rationalize that, I can, and it's going to be 5 radical 3 over 3. So A is 5 radical 3 over 3. And then I know that my hypotenuse is 2 times A, which is going to be 2 times 5 radical 3 over 3, which is 10 radical 3 over 3. So I come back over to this main drawing, and I'm like, okay, this little piece here is 5 radical 3 over 3, and this hypotenuse is 10 radical 3 over 3. And so this is 10 radical 3 over 3, which means this is 10 radical 3 over 3, which means this is 10 radical 3 over 3. And again, if I'm doing my perimeter, I know that it's 3 times 10 radical 3 over 3, because that's what x equals. Now, thankfully, this 3 and this 3 cancel, and I see that my perimeter is just 10 radical 3. And that is my final answer. So again, I can do the math and I can get it, and I know this is units, whatever units they are. So again, I had to break it into kind of like this half of the triangle to figure out what A was, and then I could use that to find what the hypotenuse was. So in sum, you can find the missing sides of a triangle first by Pythagorean theorem if you have 2 of the 3 sides. If you only have one side, you're looking for special right triangles in the hopes that you can use that. And again, it's only for 45, 45, 90, or 30 and 60 and 90 degree right triangles. So it only works, the things we learn in this section only work for these 2 triangles.